Hi everyone, I hope you're all staying safe and keeping healthy. In this episode of Vaccinate India, we will be talking about the development of the COVID-19 vaccine, its role in ending the pandemic, and what some of the terms we hear associated with the vaccine, such as efficacy, actually mean. Along with this, we will be discussing frequently asked questions such as what happens when the vaccine enters our bodies? Why should someone take the vaccine if they can still contract the virus? What is the long-term protection of the vaccine? And so much more.
Yes, Dr. Gagandeep Kang will be helping us answer all these questions. She is one of India's leading virologists and a pioneering scientist when it comes to the development of rotavirus vaccines. So why don't we just go and hear more from her? Good morning from London, and hope you're doing well. Dr. Kang, would you mind just introducing yourself to our audience?
I'm Gagandeep Kang. I am a professor of microbiology at the Christian Medical College, Vellore.
So just to start off, could you explain for a layman, from the time of the first shot and the vaccine enters our bodies, what happens?
Vaccines are set up to mimic infections, which is that the body recognizes whatever has entered as being foreign and responds to it. That response is made over time. It sort of increases in the weeks following vaccination. Then you develop the ability to, if it's an infection, kick out the pathogen. And if it is a vaccine, be ready the next time this pathogen comes around, because you now have the tools to recognize this invasion by a foreign substance and do the best you can to get rid of it. This period of making antibodies starts at a minimum about 2 weeks after you get vaccinated. And the key antibodies really kick in only after 3 weeks. It depends on which vaccine it is, but they can take up to 8 weeks to reach a maximum. And then they slowly decline with time. And this period of decline can be over several months. That the absence of antibodies does not mean that you are not protected from infection. The purpose of giving more than one dose of vaccine is really to make sure that you have the maximal protective response for certain kinds of vaccine platforms.
People are getting the disease even after the vaccine. So many are asking, what is the point then of taking the vaccine?
It's important to understand that vaccines are not actually intended to prevent infection. The intention of any vaccine when you first make it is to prevent disease. And you want to make sure that people don't get sick because they've been infected with this organism. The fact that many of the vaccines that we have actually decrease infection also is a useful byproduct, but is not the goal of vaccination. The goal of vaccination is to prevent severe disease and prevent people dying because of SARS-CoV-2 infection. And vaccines are doing this very well. They are also to some extent able to protect against mild disease or infections, but that there is lower efficacy than against severe disease.
Would you compare this to the influenza vaccine that a lot of people in the West take? Is it a similar kind of vaccine?
This is so much better than the influenza vaccine. I can't even begin to talk about it. You know, when we first started out thinking about making SARS-CoV-2 vaccines, we thought they were going to be like influenza vaccines. Like a year ago, the best we were expecting from vaccines was a vaccine that worked like an influenza vaccine. So what we asked for was 50% protection that lasted at least 6 months and a vaccine that was suitable for adults. You can see our hopes of having a successful vaccine were not very high at the time, And now we've gotten to the stage where we are saying, oh, 90%, but that one is 95.
The speed or the collaboration or the innovations that have gone into this tiny prick that we are getting the world over. I mean, when you think of it, it's just unbelievable.
This is the joy for a vaccine scientist. You have so many failures. When you're trying to make vaccines, all kinds of reasons for them to fail, for even what you hope will be very successful doesn't work out. And finally, here you have a pathogen that is very amenable to vaccines, where all of the science that we've been developing for 20 years is actually working out for this pathogen. So it's very, very exciting. And it gives us hope that we will be able to work this fast in the future or even faster. It won't be possible for all pathogens. We just got really lucky with this one, that this was very tractable to vaccines. And we were able to apply all that we know about safety, about efficacy in the design and in the testing of these vaccines.
You know, for a layperson, it's very hard to judge, let's from a journal article or test data about what is safe and what is not safe. We listen to scientists, we listen to doctors when they say that, okay, if the vaccine is 75% safe, then it's good for you, you should take it. So could you tell us, how do doctors look at this data, what is called efficacy data, and can we trust it?
Coming to the efficacy of vaccines, in that study, you do it usually in thousands or tens of thousands of people, half of whom will get vaccine and half will not get the vaccine, or they will get a comparator vaccine. And here you're looking to see what happens in the vaccinated group. If the vaccinated group get less disease than the unvaccinated group, then the vaccine has worked. So let's say we had 10,000 people in each group. 10,000 got vaccine, 10,000 did not get vaccine. Now, in the unvaccinated, you followed them for 6 months. In the unvaccinated, 1,000 people got sick. 1 out of 10 people got sick. You look at the 10,000 that received the vaccine, and only 100 people got sick. What is the vaccine efficacy? You expected 1,000 cases. You got only 100. So the vaccine is 90% efficacious. It does not mean that 9,000 people are protected and 1,000 people are not. It means that the amount of disease in the whole 10,000 population is reduced by 90%.
I remember from my high school biology class, you know, when we used to learn about immune responses, there were these cells called memory cells. And so I remember when I was a child, I got, let's say, the measles vaccine, right? So how does our body remember for some diseases for so long, for so many years, that we will not get it, 30 years, 40 years? Can this happen with this vaccine? That do we know that it will happen with this vaccine, that the memory will last for so long in our bodies?
We don't know how long memory will last, but we do know that memory B and T cells are being made in response to SARS-CoV-2 infection and vaccination. We expect that there will be a longer duration of protection. How long, we don't know. And usually when you have an infection that is a mucosal infection of the gut or the respiratory tract, you don't get perfect protection. It's very, very rare. So what we are looking forward to with this virus and the vaccines we have against it is understanding how long protection lasts. And that protection will be mediated by memory cells. It may not last forever. Will we need a booster every year? Will we need a booster every 3 years or 5 years? We don't know. It's an interesting situation to be in because we still have so much to discover. But we are in the fortunate place of understanding that vaccines really do work. And if we use them, and enough of us use them, then we can generate information that will allow us to derive the maximum benefit from vaccines. And if we need to design new ones, we will.
just a last thing before we go is that vaccinating ourselves, I mean, it's like protecting ourselves in packs, right? I mean, that's what we are doing. It's not just for us.
We vaccinate ourselves to protect ourselves. But the more of us that are vaccinated, the more we protect our communities. There are always people within our communities that, for one reason or the other, are unable to protect themselves through vaccination. These are people who are older, people who are immunocompromised, people with cancer and chemotherapy, undergoing radiation, people with transplants who have to take immunosuppressive therapy, even people who have other immune suppressive conditions. And if we are protected, then we are protecting them indirect. So it's our responsibility, I think, to be vaccinated so that we decrease not only our own illness, but our ability to spread illness to others. And that's one of the incredible things about the vaccines we are seeing now. The latest study from the UK shows that there is a 50% reduction in household transmission in people who have received even one dose of the Pfizer and the AstraZeneca vaccines, which just goes to show that these vaccines can slow this pandemic.
Thank you so much, Dr. Kang, for your time. This has been so good. Thank you and have a great day.
You too.